What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So this is part 5 of our Pandas tutorial series in Python. So in this video, I told you in the previous video that we are going to explore more of the querying methods or techniques that Pandas data frames supports. So, without any further ado, let's get to it. So I should mention that we will use the data frame that we had and worked with in the previous video. If you are not following along, I will just show you the code really quickly. So this is the code here. Go ahead, create this data frame, and we will work with this. So let's get to it. Now, first things first, I'm not going to import anything. I am just going to continue working with what we had. So what we learned in the previous video is that you have the ability to retrieve or obtain any column from the data frame using one of two ways. Okay, you do the way that is appropriate and convenient to you. So the first way was where we had the data frame name, the name of the data frame, and in square brackets in a string we will pass the name of the column. The second way we had was dot notation. So basically the name of the data frame dot and then the name of the column. So just to show you, I'll do it in the IPython console. I have data frame 2 and the columns for this data frame that I have. So I have, I will show you that now. So there they are here: year, state, pop, and det. So I can do any one of those, right? So as you guys will see, data frame dot pop, and if I hit enter, this is what I obtain. If I do data frame dot debt, oh, we already did that. Let's do year, and this is what we obtain. So it is interesting and it is cool to play around with. Now, what I'd like to show you is how we have the ability to retrieve or index certain values from the data frame using the indexer column. So just to show you again what the data frame we are working with looks like. So this is data frame 2, what we are working with right now. It looks like this. Now, I'd like to introduce you to a special attribute that a data frame supports, and it's called the loc, L-O-C. Now, loc is basically a short form for location, okay, in case you are wondering. So that is fine. Now, what we have is the ability to return values from the data frame using the indexer column. Okay, so let me show you how this works. I'll do print, so I'll comment this out. Now print data frame 2 dot loc, and within the loc or the location method, what I'd like to do and what we are required to pass is the name of the index that we'd like to retrieve. So for example, our indices here are basically 1, 2, 3, 4, 5, 6. This is because we set it to those values. In actual sense, they would have been by default 0, 1, 2, 3, 4, and 5. So if we'd like to retrieve the value at the first index, what we'd have to do is as follows. What you'll do is the name of the data frame, in our case data frame 2 dot loc, and what we'll pass, since we want the first one, is 1. When I run this, you'll see that we obtain the entire row, right? The entire row of data for index 1. So let's go ahead and do this. And as you guys will see, we get year, state, pop, and det. And all of this is for 1. As you can see at the bottom here in the little description of the data that has been returned, the type of this is object. Do not stress about that. Focus on name. The name of this index which we have just retrieved is 1, telling us that, we retrieved this entire row over there. So that's fine. Now, what you can also do using the concept of indexing and slicing is basically simple array operations. So this here was how we index a certain row. If you want to kind of modify a value in the data frame, what you need to do is the name of the data frame followed by the column that you'd like to, change or manipulate. And this now is us changing the entire column to a fixed data value. So what I'm saying is that what you specify here gets propagated to the entire column. Okay, because think about it, data frame det. This first portion of the code is the way in which we index or retrieve an entire column. And by setting that column to a value of 16.5, it tells us now that the entire, so this is the default data frame, right? Now it's going to tell us that the entire det column, all these NANs, are going to be set to a value of 16.5. Now this is often known as imputing data. It's where we place or add data into a data frame. So that's fine. Now let me print data frame 2, and as you guys are going to see, so that did not work. Why is that? So okay, so this is because I should have mentioned this earlier as well, that I used the incorrect uh, name of the data frame. So if you guys saw that I had data frame when in fact we are working with data frame 2. So just pay careful attention that you use the correct objects, in your script, guys. So anyway, this is what we have now. The det column has been set to a value of 16.5, and what does that is this code here. So easy stuff, guys. Pandas is really cool and it's easy to use. So that's fine. Now, what I'd like to show you is how you have the ability. So let's face it, right? Having a fixed value of 16.5 is kind of, I would say, boring. It's kind of bland. In the real world, you get change and variance in your values. So just to show you, so data frame det debt, and let's do is equals to, now this is me showing you that Pandas has the ability to utilize and work in conjunction with NumPy. So let me import NumPy up here in the script. Import NumPy as NP. So you guys know we have worked a lot with NumPy, especially when it came to, creating dummy data. And this is how NumPy and Pandas worked together, especially if you are a beginner learning Pandas. Your go-to for generating dummy data for your data frames can be NumPy. Okay, NumPy is powerful. And again, if you guys saw that, I had data frame and I forgot to add the 2. So just make sure you do that. Now, this is what we observe. So basically, initially we set it to 16.5, all the values in the det column, and then we change that to NumPy a range 0 to 5. So that's what the a range does. It's a normal range function in Python. So this is what we observe now. The det column has values 0 through 5. So that's fine. Now, that's me showing you that NumPy and Pandas are powerful. You can use them together. Okay, so you see, what I'd like to mention to you is that when we are assigning lists or arrays to the column, right, the length of the values must match the length of the data frames column that you are working with. If we assign a series, the labels will be realigned exactly to the data frame's index. Okay, it will insert the missing values in any missing values that you have. So if that made sense, don't stress. If that did not make sense, don't stress. I am going to demonstrate what I mean right now. So you guys know we have this as our current data frame. The det column has 0, 1, 2, 3, 4, and 5. Now, suppose what I'd like to do is basically I want to set the data frame det column debt. I want to set this to a value of n. So let's do numpy.nan. Now this is an actual method available to us from NumPy. It's the numpy.nan, and what it does is it will set your column to NaN value. So this is just us restoring the det column to how it initially was. Okay, so what you guys will notice as well, I've said this many times before, pay careful attention to the various methods and techniques that arise as we explore a certain technique or method. So see, just by me trying to show you now how you can have the ability to insert a series into a data frames column, we have realized and just noticed that numpy.nan is an actual technique that exists, and we can use this to impute or fill in missing or null values in certain, rows or cells of the data frame. Now, that's fine. Now, this is what we have for the existing data frame. The det column contains NaNs or nulls or missing values. Now, I'd like to show you this really quickly. So what we are going to do is I am going to create a series object. So pd.series, I will open a parenthesis. Within this, I will pass my data in a square brackets in the form of a list. Let's do -1.2, -1.5, and -1.7. I am only passing 3 values. Now, index is equals to, in another list, I am going to say 2, I will say 4, and I will say 5. Now, pay careful attention, guys. This is all respective. What I'm saying is that the first value is going to be assigned to the index 2 in the data frame, the second value to index 4, and the third value to index 5. Okay, that's why I say it's respective. The order in which you pass the indices is basically the order in which the values are going to get mapped to. Now, let's go one step further. I'll do data frame 2, and we are working with the det column, and I'm setting this equals to val. Now, before we actually run this, I just want us to view what val looks like. So val, this is what it looks like. It's a pandas series. Okay, now let us do this. So data frame 2 det is equals to val. This tells us now, right, that the det column, we are going to take this series and we're going to insert it in the det column. Now you may ask, before even running the code, you may ask, think about it, this series has 3 values, and in the data frame column in which we are inserting, it has 6 values. So the question is, what happens? Now guys, this is what happens, right? You see the indices in the series, they basically get mapped and filled. The values get mapped and filled to the matching indices in the data frame. The indexer column is the one that takes care of this. So basically, 2. In 2 here, we are going to see the value -1.2. In index 4, we will see the value which is -1.5, and in index 5 we will see -1.7. So this is interesting for you to know. Let's go ahead, let's run this. As you guys see, that is exactly what we obtain. So the point of all my tutorials on the channel are really to cover everything as much as I can, pertaining to the certain topic that we work with. So most of the time, I will highly recommend that if you are the type of person who learns and upskills in your leisure minutes or in your spare time, then my channel is going to be your best friend. If you are a beginner in any of the topics that I teach on the channel, that is really all you will need to know for that specific topic. Okay, so yeah, that's fine. With that, let's move forward, guys. This is an interesting session. Now, as you guys know, right, we know how to add or create a new column to the data frame. We did this using the following kind of syntax, right? We passed the data and then we just defined extra columns in the column parameter. Now, there are several other ways to actually create new columns to your existing data frame. So the data frame we are working with at the moment has 4 columns: year, state, population, and date. Now, another way in which you can create a new column is to simply do data frame, pass the name of the column that you'd like to, create. So what we will do is, let's just call this Eastern, and pay careful attention, guys. What I'll do now is, so let me do is equals to, and let's set this to numpy.nan. So this is the other way, the next way in which you can create columns in your data frame, or for your data frame. So it's not showing up here because I keep forgetting the 2, but that's fine. See, this is another easier way in which you can create new columns for your data frame. All you have to do is just the name of the data frame, the name of the column you'd like. Remember, Eastern is a non-existing column. In essentially what we are doing in this line of code, we are creating a new column by the name of Eastern, and we are kind of appending it to the existing data frame 2, and that Eastern column is being set or given the values of NaN that will be propagated through all rows in it, which is as we see. Now, to take this one step further, we have the ability to do Boolean conditionals, on a certain column. So basically, based on one column, based on the value in one column, we can set another column's values to be a Boolean true or false by using that other column in a condition. So that was kind of hard to explain. It's going to make much more sense when you see it in action. So what we're doing is, you see the Eastern column, guys, data frame Eastern, which is basically the Eastern column. What we are going to do now is we are going to set the Eastern column equal to a Boolean value based on the state. So what I'll do is data frame Eastern is equals to data frame 2 dot state is equals to Ohio. So this is easy, right? This is easy conditionals. This is the condition that is being tested. Data frame 2 dot state is equals to Ohio. Essentially what this means is that wherever Ohio appears in state, the Eastern column will take on the appropriate true value. Otherwise it will be false. So Control Enter, and as you can see, wherever Ohio is set to the state, the Eastern column will take on a Boolean true. So that's basically us doing conditional imputing. So let me comment this here. Conditional imputing with Boolean values. So that's good. Now, that is good. Now, what I'd like to show you as well is that you also have the ability to delete columns from your data frame. And to be honest with you, the most easiest way to do this is to utilize Python's del keyword. This is built into Python. The chances are really high that you've came across this specific keyword before. It can be used to delete literally any object that exists in your script. So as you can see, right, just to demonstrate, I have an error here, undefined name data frame 2. It is saying this because the line above says del data frame 2. So basically I attempt to delete it, and then I am attempting to print the object to the screen. So Python kind of registers that. Anyway, to delete a column from the data frame, all you do is the name of the data frame, in our case data frame 2. You can use a dot notation to refer to the column, or you can use our square bracket notation, so Eastern. And as you guys are going to see, the Eastern column has been completely removed from the data frame. So that is good. Now, what you'd like to do is, if you'd like to always, it's always good to know this. If you would have, sometimes you need to look at, the columns that exist in your data frame. So what you'd like to do is the name of the data frame followed by dot notation, and this is a method that data frames support, dot columns. So let me comment that. So when we run the script, guys, so I will just comment this out here. Now control enter, and as you guys are going to see, we basically obtain a sort of object that tells us or gives us in list form the names of the columns that exist in the data frame. So pay attention that the eastern column has been removed, so it does not show in the list itself. So that's fine. Now what we also can do, you see, oftentimes, right, what you may come across is a very common form of data is a nested dictionary of dictionaries. So let me just comment this here, and this will just be for extra information, right? Another common form of data is in the form of, or let's say is a dictionary, a nested dictionary of dictionaries. So that's fine. Now I'd like to give you a small example of what I mean. So let me show you how this works with a data frame. So first things first, go ahead, import pandas as PD. Next, I'd like you to create a dictionary object. You can call yours anything you like. I'll call mine population is equals to, this is going to be set equals to a dictionary object. So within this, I'll do Nevada. So I spelled that correct, right? Nevada, and the value. Now remember, guys, Nevada is the key. Now the value to this key is going to be another dictionary in itself. So what I'll do here is as follows. I will do another key object, so we will make these numericals, so 2001, and I'll make this 2.4. Next I'll do 2002, and I'll make this 2.9. Now this is just one object or item in the dictionary itself. For the next element in the dictionary, I'll do Ohio, and this will be another dictionary as the value to the key Ohio. So what I'll do is 2000, and here I'll do 1.5, and another element will be 2001 followed by 1.7, and the third element will be 2002, and here we'll have 3.6. Now this is the dictionary that we have. It is kind of I would say confusing to look at first because of the fact that it is a nested dictionary in Python. So I will just space these out a bit to avoid confusion to you. So we have that. I'll make these appear on new lines. Okay guys, so that is a bit more easier to look at. Now pay careful attention, guys, because what we are observing here is basically a nested dictionary. It's a dictionary that contains other dictionaries. Now what we are going to do is we are going to attempt to create a data frame from this dictionary object. Now you guys saw, right, it was relatively easy to develop or create a data frame from a single dictionary. This is a single dictionary. It is non-nested. Now what we have here is a nested dictionary. Now what I'd like to bring to you guys' attention before we actually run the code, right, is you see Pandas is going to interpret the outer dictionary keys as the columns. What is the outer dictionary? The outer dictionary is the main one, and the keys we have here are Nevada and Ohio. So those are going to be the key or the keys or the column names for the data frame, and it's going to interpret the inner keys as the indices of the row. What are the inner keys of this dictionary object? The inner keys are, so this is the inner dictionary here. The inner keys are 2001, 2002, 2000, and so on. That's going to become the row indices. By row indices, that means it is going to make or form part of the indexer column. okay, and these values we see here, 2.4, 2.9, 1.5, and so on, they become our values, our data values that are propagated into the cells of the data frame itself. So that was just an explanation. Now it is time for us to actually view what this data frame object looks like. So let's do population, print data frame, control enter, and as you guys can see, we get that. So I hope you guys find this interesting and it does make sense to you. Now, what we can do as well with data frames is we have the ability to swap the rows and the columns. Okay, if I'd like to bring this into perspective for you, you see NumPy arrays also support a similar transpose method, and the logic is exactly the same when applied to data frames. So we swap the rows and columns. So swapping the rows and columns of a data frame, it is known as transposing. Okay, you transpose the data frame. That basically means you swap the rows and the columns. So let me show you how this works. What I'd like you guys to do is just go ahead, copy the previous data frame that we worked with. So I'll just copy this entire cell here. And when printing data frame, I would like you to do print data frame dot t, a capitalized T, guys. The uppercase T, that is basically the transpose method that can be called on a data frame object. So essentially what's going to happen now is that rows are going to become columns and columns are going to become rows. So think about it, right? At the moment, these are the column names. Now these, when it's transposed, become the indexer column. So it's basically the indice column we find on the right, or on the left rather, and the indices we see here, 2001, 2002, 2000, that's going to become the column names. So row names become column names become the row names. Now when I run this, control enter, as you guys can see, the data itself does not get changed or manipulated in any way. It is still assigned to the appropriate column and row. It's just that the data frame itself has been transposed. So the shape of the data frame does change in some way. So just to give you a bit of insight, right? Data frame dot shape. The original data frame is a 3 by 2, and let's do data frame dot t dot shape. That becomes a 2 by 3. So that is what we have for the transposing operation. Now that's fine. What I'd like to do now, guys, is I would like to show you, right, how we have the ability to actually name the indexer row and the indexer column. So basically, you guys know, right, we have a header row. So let me do away with the transposing of the data frame, or unless maybe you guys want to actually work with this, I think we should work with this. So let's do data frame is equals to data frame dot t, just to give you guys some hands-on practice of working with a data frame that has been transposed. Okay, so there's no need for the dot t. This is the transposed data frame that we have, and this is what we will work with at the moment. So what I'd like you guys to just know is that you have the ability to name the indexer column, which is basically the extreme left, and you can name the header row. So let me show you guys how you can do that. So what I'd like to do is data frame dot index dot name is equals to, so the indexer row here is basically a state. So let's go ahead and appropriately and logically name this state. Now what I'd like to do, data frame dot columns dot name is equals to, so the columns themselves, they depict 2001, 2002, 2000. Those are years. So let's appropriately name this year. Okay, so now when we print the data frame, this is what you observe. You have year that shows on the top here, that's the header row, and then you have state, which are the indexer rows. Okay, so I hope that makes sense to you guys. Now, I am going to end the video here, but before we end, maybe just one more thing that I'd like to show you guys. It is relatively easy to understand. You see, sometimes when you'd like to return your data frame in an array representation of format, all you need to do is just print data frame dot values. By doing data frame dot values, essentially what you obtain, as you will see, is an array. This is an array of really just your data. So that is good for you in case you'd like to experiment with your data frame in any way that you like. So data frame dot values will give you an array. So we can double check this if you'd like. Print type data frame dot values, and this is interesting for you guys to see. It is a numpy array. Okay, so that tells us that the data frame in the series object, the collection that lies underneath, apart from the dictionary, it is also a numpy array. So that's what we have there. Now, what I'd like to do for this video is about that much. That's mostly it. Now, just to show you guys one more interesting thing, you see, we were working with the following data frame in the initial stages. So if you have been following along, you will also have this data frame with you. So go ahead, guys, copy the code that actually creates that data frame and bring it down, paste it. And I want to show you guys one more thing. So print data frame. So this is what we have here, state year population. Now, why I am doing this again is because you see the values we worked with here was only numbers. I want you guys to see what effect the data frame.values method has when you are working with a data frame that has a mixture of data types. Okay, we have floats, we have integers, as well as strings. So this is what you obtain, a very well formatted array, multi-dimensional array that contains values only from the data frame. So we are going to end the video here, guys. This is all that I'd like to discuss for this video regarding pandas package in Python. I do hope you found this tutorial interesting and this video interesting. We will explore pandas much more in the videos to come. And with that, guys, thanks for your time. Thanks for watching. Good luck with your work, and I will see you in the next YouTube video.